Hey everyone, welcome to the Rev Games Academy. Today we're going to learn about procedural animations, a technique that brings characters and objects to life in ways that traditional, keyframe-based animations can't. Instead of presetting every movement, we use code to generate real-time animations, making them dynamic and responsive to the environment. Think about it, a character automatically adjusting their feet on uneven ground, or an object reacting to a collision in real time. Sounds cool, right? Well, in this video, we're going to break down how procedural animation works and how you can create it in Unity. There are many types of procedural animation, and even particle system in Unity is a way of these animation. In Unity, the particle system component allows for procedural animation of particles by defining the behavior through various parameters, such as force, velocity, rotation, color over time, and lifetime. It's not keyframed based, but generated dynamically at runtime, which is why it's considered procedural. As I mentioned earlier, you can create your own procedural animations using code or even mathematical calculations. In this scene, I've implemented a simple script that detects obstacles and makes the character jump based on their height. While this may not be the most advanced procedural animation, it provides a basic understanding of how we can use logics to dynamically influence animations in real time. When it comes to this type of animation, Unity provides a powerful tool called animation rigging. It's a constraint-based animation system that lets you blend traditional keyframed animations with procedural adjustments in real time. Instead of relying only on pre-made animations, you can dynamically modify bones and joints based on gameplay conditions. The animation rigging package includes many predefined constraint components that help you create flexible and responsive procedural animations. One of the main advantages of animation rigging is its easy bone renderer setup, which makes it much simpler to visualize and select bones directly. To get started with animation rigging, we first need to install the animation rigging package from Unity's package manager under the Unity registry. Once installed, the package appears in the menu bar where we can access these options. As we have discussed, one of the most useful features is the bone render setup, which helps visualize character bones. Normally, to access a particular bone, we have to manually navigate through the hierarchy, but with bone render, the bones are displayed visually, making selection easier. We start by rendering the bones from the hips, as it is the root of all child bones. Once enabled, we can see all bones rendered in the scene view, and clicking on any bone, like the head, takes us directly to its corresponding object in the hierarchy. The bone render also allows us to adjust the size and color of the bones. We can see that all the transforms have been added here, allowing us to visualize and manipulate the bones easily. And if the character has a complex structure, we can individually add transforms for more control. Before using rig setup in animation rigging, it's important to understand about constraints and rig. Constraints define how bones react to the movement of other related bones. As we have discussed, Unity has different types of built-in constraint, like this two-bone inverse kinematics. Here you can see that when the constraint is not added, moving the foot bone doesn't affect the other bones. However, when the constraint is added, moving the foot causes the entire leg to react naturally, creating a more realistic and dynamic movement. In animation rigging, a rig is a collection of constraints that influence a character's bones or transforms, enabling procedural animation and real-time modifications. It serves as an extra control layer on top of existing animations, allowing for dynamic bone interactions. For example, when I play this keyframed animation and move the constraint, you can see the leg adjusts accordingly. However, when I disable the rig's influence, the animation returns to its original keyframed motion. If you'd like a deeper dive into each constraint, its properties, and how to use them effectively, let me know in the comments. I'd be happy to cover more detailed explanations and practical examples in future videos. Let's get back to the scene. So far, we have added the bone setup, And now it's time to start setting up the rig. We can either add this manually via the Add Component menu or use Unity's Rig Setup options. When we add the rig builder, Unity automatically creates a rig object where we can define and assign constraints. The rig builder component manages rigs and determines which one is active. To demonstrate the animation rigging system, we'll use a multi-aim constraint to make the character's head track a target object. First, we create an empty game object and name it Head Tracking. Then we add a multi-aim constraint component to the rig. When an object is moving and you want the head to follow its direction, this constraint becomes useful. For the constrained object, we assign the character's head bone, since we want it to rotate in relation to the target. Next, we create a sphere and assign it as the source object, which will act as the target that the head follows. We position the sphere in front of the character and adjust its placement in the scene. Initially, the character's head doesn't follow the sphere. This is because animation rigging only works in preview mode or at runtime. Once the scene is running, the head starts tracking the sphere's position. The multi-aim constraint overrides the keyframed head movement in the idle animation, while still allowing the rest of the animation, such as leg and hand movements, to play normally. As we move the sphere, the character's head smoothly follows its direction. The properties of the multi-aim constraint allow us to fine-tune the movement, adjusting factors like rotation limits and responsiveness. However, changes to the world up type setting won't have any effect during runtime because by default, only the weight property of a constraint can be dynamically modified at runtime. Now, you may have seen the weight property influences the constraints over an animation, but what is weight? The weight property in Unity's animation rigging controls the influence of a constraint on the assigned bones or objects. It acts as a blending factor between the original animation and the procedural animation applied by the constraint. Here you can see that the head's movement is influenced by the constraint, overriding its keyframed animation when the weight is set to 1. However, when the weight is set to 0, the constraint is disabled and the head follows its original keyframed animation as expected. This setup showcases the power of animation rigging, where procedural adjustments blend seamlessly with traditional animations, making character movement feel more natural and responsive. Don't forget to like, subscribe, and ring that notification bell to stay updated on more tutorials. Thanks for watching. Catch you in the next video.